So we know that the Earth orbits around the Sun, but does it share that orbit with other objects? And if it does, have we actually found any? Well, first, let's just consider what an orbit is. So we know that the Earth goes round the Sun on an orbit, so it will almost cover the same location it went before. Same with Venus, shown here. And each object in the solar system is going to be on its own orbit. Now, that obviously scales outwards as well. So if you go further out, the outer parts of the solar system, like the Oort cloud, even those objects are going to be on their own orbit. And that's assuming they're actually part of the solar system. So there are objects that can come in and go out, but if they're gravitationally bound to the sun, then they're going to be on their own orbit. Now, are they on their own orbit? Can they share it with other ones? Well, the first thing we need to consider is Lagrange points. So the definition then of Lagrange points are these are points of equilibrium for a small object that's under the influence of two more massive objects. So one of those more massive objects will be orbiting the most massive object. Now, as an example, we'll take the Sun and the Earth. So those are our two massive objects. The Earth is going around the Sun. And if you had a small object, which would be considerably smaller than those two, then there are locations in and around that orbital configuration where they would be in some form of equilibrium. And the size of those objects is going to be kind of asteroid size, satellite size, because we use satellites in those locations as well, actually. But to put it in a more visual context, you can see them here. So we have 5 Lagrange points. Now, the first 3, L1, L2, and L3, are in a line between the Sun and the Earth. And they're not particularly stable because you can move away from those quite easily. They're not bound there particularly well. Now, it's worth noting also that this is in a rotating reference frame. So as the Earth goes around, those 5 Lagrange points move so they're still in the same configuration. When the Earth's on the opposite side, then it would look like this. So you still have your L1, L2, L3, the L4, L5, but they would basically move around with the Earth. Now, the L4 and L5 are stable. What that means is that any object located in those sorts of locations are going to be orbiting them. So they will actually orbit the points themselves, as opposed to the first 3. If they moved away from those points, then they're going to move off into space and continue on their way. But the L4 and L5, they would actually orbit the point itself. So they're a bit more stable. They will remain there instead of being knocked off course. So the biggest example of objects located here in the solar system is around Jupiter, and these are known as the Trojan asteroids or co-orbital objects. And there's very large collections located in front and behind the orbit of Jupiter. So 60 degrees in front and 60 degrees behind, you have these collections of objects. And again, these all orbit around that central point in those locations. So they'll kind of move around independently there. And from the reference point of Jupiter, they can appear to have kind of chaotic orbits, really. So they move in a very unusual way. If you're located on Jupiter, they will do some fairly chaotic looking movement in the sky as you look at them. Now, to give you an idea of how they're actually moving in that reference frame, then these green objects here are those co-orbital or Trojan objects that are located at the L4 and L5 Lagrange points, and you can see they're kind of moving around and almost orbiting those points. But you have to remember that these are actually also going around the sun as well. So if you tracked out their actual movement, they'd almost kind of make spirals as they went around, so it would look very unusual. But Jupiter has the biggest collection of these objects in the solar system. Now, where do they actually come from? Well, they're lightly captured objects. So as objects get too close, and if they're at the right sort of velocity, they can get gravitationally captured, and then they remain there kind of moving around these points. But the other thing is, well, they can get captured, but they can also leave those points. So they can be temporarily captured, and then later on they are ejected or they're kind of perturbed and they leave those orbits around those L4 and L5 Lagrange point, which is true for Earth. So Earth can capture objects into these unusual configurations, and then later on they can be removed. But what do we actually know so far about these co-orbital objects with Earth? So the first one is 2010 EK7. This is a 300-meter diameter asteroid or minor object located at L4. And there's an image there of it which is circled. Very hard to actually see. And again, they're not easy to actually spot these things. And the orbit of that from Earth looks like this. So again, it looks very unusual, somewhat chaotic, but it's moving around that L4 point back and forth. And you can see, if we do this, it's quite difficult to figure out whether they're actually stable or not, whether they will be lost in the future. But the second one is 2020 XL5, and this is a slightly bigger object, so it's about 1.2 kilometer diameter. Again, located at the L4 point of Earth, but this time around the orbit looks a little bit different. You can see how it looks different to the previous one. And this one, so modelling and simulations have suggested that this is likely to last about 4,000 years before it is then lost and it moves away from being in this co-orbital configuration, and it will basically be perturbed by other planets moving nearby. Now, they are very difficult to see, as I mentioned. The reason why they're difficult to see is they're located almost on the day side of Earth. So if you're looking from Earth, you need to be looking in the sky when the sun is just setting or just rising and the sky is still light, because it's on the day side as opposed to the night side. So they can be very difficult to actually see. Because if you look at the sky around about the time when the sun is setting, even an hour after it, there's not that many bright or many stars in general in the sky that you can actually see. You need it to get very dark to see it. So to see a small object located at these locations can be very difficult. So thank you for watching, and if you enjoy, then check out some of the other videos.